Hello and welcome to this video on interpreting graphs. And this is in the sense of interpretations of graphs that are drawn for you. And I'm pulling my example today from an intermediate algebra text. So it's nothing too involved. This is mostly geared toward or aimed at people in a beginning or intermediate algebra course. So if you're here to talk about interpreting graphs at the calculus level where you're looking at derivatives and whatnot, this is not the video for you. Okay, so those of you still sticking around, I've got just one example to show what a good graph should look like, and how we should be able to look at any graph if it's well drawn, well written, well labeled, and answer some questions about it. All right, so here we go. So my only example in this video here is, see, I've got the graph shown. Yeah, it's not on graph paper. I probably could have done this a little more neatly. Maybe you should on your own. There's some rulers or some graph paper, but it's still properly labeled. So the graph shown represents the cost represented by this capital C, and the cost C is in thousands of dollars, right? So when you're seeing down the vertical axis here, capital C, that 900 means $900,000. That's $800,000, $600,000, right? So the graph represents the cost C in thousands of dollars of refining X gallons of gasoline per hour, where this X represents thousands of gallons of gasoline per hour. So you see down here number of gallons of of gasoline, number of gallons in thousands. So this means 50,000 gallons of gasoline per hour, 100,000 gallons of gasoline, 200,000, etc. gallons of gas. Alright, and as mentioned, the vertical axis represents the cost, the capital C mentioned there, in thousands of dollars, labeled on the side. And the horizontal axis, going to left to right here, represents the number of gallons of gasoline refined, which they mentioned was represented by the letter X, the variable X. Great. And what I've got here is a little light blue graph with some special points marked off in purple. This is the graph of the relationship between the number of gallons of gasoline refined in an hour and the cost of refining those gallons of gasoline. And again, the number of gallons is in thousands, cost is in thousands of dollars. Alrighty, so let's take a look at this. This is what a good graph should look like. Axes are properly labeled. The markings on an axis are consistent. Right? Notice my notches, all the horizontal axis, all the markings are 50 units apart. 50, 100, 150, 200, etc. And that remains consistent for the horizontal axis. Additionally, all my markings, all my notches on the vertical axis are consistent with each other. Every marking on the vertical axis represents a difference of 100 units. 100, 200, 300, 400, 500, etc. Just so long as all the markings on the horizontal axis are consistent, mean the same distance, all the markings on the vertical axis are consistent and mean the same difference. That's a good graph. Starts off at 0 for both of them, right? This 0 down here means 0 gallons of gasoline in the horizontal, or 0 thousands of gallons of gasoline, but 0 gallons of gasoline in the horizontal, and $0 in the vertical. Also, a good graph should be properly labeled, right? The vertical axis is labeled with the variable these numbers represent. The horizontal axis is represented is labeled with the variable that those numbers represent. And even off on the vertical axis, you even see what that variable represents, the cost in thousands of dollars. And the horizontal axis, same thing. What the X represents is number of gallons of gasoline refined, right? Number of gallons in thousands of gallons. And on the graph itself, some certain special points that we're going to be asked about are labeled, where as in any ordered pair, when you're looking at like the XY coordinate plane, or in this case the XC coordinate plane, the first coordinate of the pair is from the horizontal axis, representing the number on the horizontal axis, and the second coordinate in the ordered pair represents a number in the vertical, all right, for the vertical axis. So I've got the point here 0, 100 labeled, 250 for the horizontal, 200 for the vertical there, that point, 400 for the horizontal, 350, a little bit between 300, halfway between 300 and 400 there, 350 for the vertical, and then this point up here, 700 for the horizontal, and in line with 900 for the vertical. And then there's a lot, infinitely many other points. All the blue points that are drawn are also points on this graph. So you can see that, if we want to make a little more interpretation here, you can see that, from this point to this point, if you said, how much would it cost this company, if there's a company involved, I'm sure, refining this gasoline, how much would it cost this company to refine 100,000, right? Remember, this 100 means 100,000, 100,000 gallons of gas in an hour. Well, I go to the 100, I go up, where does that correspond to on the graph? Looks like around this point right here, right, little dot there. And that looks like a little under $200,000. Remember, every number over here represented $1,000. And you could be asked questions like that too. Or the other way around, if I said, if it's costing the company $600,000 to refine the gas, the gasoline in an hour, how many gallons are they refining per hour? So I go to $600,000 over to where it corresponds on the graph, the point it corresponds to, right, this point right here, a little dot, and then straight down, looks like around 550. All right, remember, each notch down here is 50 units apart. Looks like around 550,000 gallons of gasoline per hour would cost, $600,000 for this company. So you can be asked both things. You should be able to interpret. And another thing you can see too is that, hopefully this would be obvious. It looks like the graph is, going upward as I move from left to right, meaning that as the number of gallons I refine increases, the cost is also increasing. Right? If I'm looking at another graph and it's going down as I move from left to right, that means as one variable increases, the other one decreases. Right? There's all sorts of ways to interpret. Lots of questions you could be asked when given a graph. And I have just four such questions about this graph here. Right. So again, properly labeled, points labeled, axes labeled, markings on the axes are consistent, right? All features of a good graph. Alright, so the first question is simply, what is the cost of refining 250,000 gallons of gasoline per hour? So notice here they gave us an amount of gasoline, right? 200,000 gallons of gasoline per hour. So I'm on the horizontal axis. Remember, the horizontal axis represents numbers of gallons in thousands. Now people tend to make a mistake here and say, oh, 250,000. Like, oh, I go out to 250,000, but that's way out there. No. Remember, every number on the horizontal axis represents thousands of gallons. So I'd go to the 250, which would be here. Right, this marking right here, 200, 250. Every marking on the horizontal axis is a consistent 50 units apart. And we see we have a point on the graph with that horizontal value, that x value, and that's already labeled here, 250, and that's in line with 200 on the vertical axis. So to refine 250,000 gallons of gasoline per hour, it's costing this company $200,000, right? Remember, this cost over here is in thousands of dollars. So, and as in most word problems, I'm going to answer this in a complete sentence. The cost of refining 250,000 gallons of gasoline per hour is, and we're seeing again from the picture, interpreting the graph, $200,000. Put a little dollar sign there, 200, and I'll just make it the number $200,000. And you can circle it or bubble it or something, right? But that's how I would answer this question, right? It is a question, a word problem. Answer in complete sentences and make sure units are involved on the numbers, right? The dollars unit is on this number to give it meaning. Great. Again, that's hopefully it's easy to understand what number is coming from what variable, right? They mentioned the gallons of gas. Oh, that's a number on my horizontal axis. And when they say what is the cost, the unknown here, what I'm trying to find, cost is I'm looking for a number on the vertical axis that corresponds to that 250,000. All right. So I've got another similar question here, part B. What is the cost of refining 400,000 gallons of gas per hour? Same thing. The number given to me is a number of gallons of gasoline refined per hour. So gallons of gas, that's a horizontal number, so I go to 400 on the horizontal axis. This represents 400,000 gallons of gas refined per hour. Go up to the corresponding point on the graph. That is again nice and labeled here, and it looks like the cost, the gasoline is 400, right, 400,000, and the cost is 350. This is in line with 350 on the vertical axis, the cost. And remember, that's not $350, that's $350,000. So just like the part A, the way I would answer this, right, is the cost in a full complete sentence with units attached to my numbers to give them meaning. The cost of refining 400,000 gallons of gasoline per hour is this $350,000 that I'm seeing in the graph, right, with that labeled point. So dollar units, and then I'll just write 350 and throw the thousand there. Right, maybe put this in a bubble or something. Right, $350,000 is the answer there. Okay, and as I mentioned, they could ask other questions involving the cost. Like I said earlier, if it costs them $600,000 for an hour to refine gasoline, how many gallons do they refine in that hour? It looks like about 550,000. Right? You go to the cost value and see what corresponding X value is with that same point. All right. Now my next question, and more about thinking about the problem, thinking about the context. So in the context of the problem, can you explain the meaning of the graph ending at 700,000 gallons of gasoline, per hour? Technically should be there. So you see on my graph, notice the graph doesn't continue on. There's not like an arrow up here. I start off at 0 gallons and it costs $100,000, and then up to 700,000 gallons per hour. And then it doesn't go any further, right? There's an end to the graph. There's no arrow continuing it on. So why would that be the case? Well, there's maybe a couple reasons. Now this is again, the title of this video is interpreting graphs, right? It's open to interpretation. We aren't given that much but a graph, but we can think about why would it end at 700,000? So one reason, perhaps that is their, that's their maximum capacity. Perhaps that, given the machine, perhaps the machinery they have, the equipment they have, only allows them to do at most, refine at most 700,000 gallons per hour. I'm going to have it involving, I'm going to make two statements, one involving the number of gallons and one involving the cost. So perhaps the equipment or the facilities that this company is refining gasoline in only allows a maximum capacity of refining 700,000 gallons per hour. Only allows the company or whatever them to be able to refine up to 700,000 gallons of gasoline per hour. Right? Maybe that's a cap that they can't breach. Maybe they're just incapable of it. They'd need more equipment or bigger facilities to do more in an hour if they wanted to. But that might be a maximum limited by the equipment they have. I hope that makes sense. All right. Well, the other, perhaps there's something to do with the cost. Maybe it stops at 700,000 here because maybe that's all they can afford to do in an hour, right? They can only afford to pay 900. To refine 700,000 gallons of gas per hour, it's costing them $900,000 per hour. I mean, so perhaps that is a limit in how much they're willing to spend, before they start losing money on the gasoline. That could be a reason, right? Again, very open to interpretation. All we're given is a graph and nothing more, but still we can interpret. We can still say something. We can still make educated guesses as to why the graph looks the way it does. Why does it end there? So again, or perhaps the company cannot afford to refine more than 700,000 gallons of gas per hour. Maybe that $900,000 that they're spending now for the 700,000 gallons of gas, maybe that's the limit to what they can spend. So perhaps the company cannot afford to refine more than 700,000 gallons of gasoline per hour. All right, and if you can think of more, write it down. Right? That's the beauty of interpreting graphs. Now it has to make sense, of course, right? They say in the context of the problem, right? That's the key phrase here. Right? What you write down, what you say, has to make sense. It has to have a meaning to the context of the problem. You can't just say, "Oh, that's all they felt like doing." I mean, you don't know that. Based on what I'm seeing here in this particular context, these are a couple reasonable explanations as to why they could only go up to 700,000 gallons per hour. Why this graph would stop there. All right. And again, add more if you wish, as long as it makes sense, right? As long as it means something in the context of the problem. All right. And the last one I've got here is identify and interpret the intercept. Now notice the only intercept here, right? They say the intercept would be the c-intercept, right? Remember x-intercepts and y-intercepts? They're just points of the graph that are on the axes, the horizontal axis or vertical axis. This has a point of the graph on the c-axis, right? The cost axis, this vertical axis, has a point there. and it has no points on the x-axis or the horizontal axis. All right, so that's why they're saying the intercept. So this point 0, 100, right, that's labeled as 0 for the x value and 100 for the cost. So I'm going to write out what that means in words, right? So this means, the value of x is 0. That means they have refined nothing, right? If they refine nothing, 0 gallons of gasoline in an hour, it will still cost them $100,000 an hour. Now, why would that be? Right, so this means that if they refine 0 gallons of gas, right, if they refine no gas, they are still paying a cost of $100,000. And the question would be why? Interpret why that would be. Right, so it's very similar to the last question where it's like, why would they end? Why would this graph end at 700,000? Well, why would it start here? Right? Why is this intercept the way it is? Why is the 0, 100 there? 0, 100 there. All right. So think about, why is it costing them $100,000 even if they do nothing? All right. They refine no gas. Well, let's think about what goes into company costs, right? This is a gas refinery. Perhaps they have, again, I'm putting perhaps. Perhaps they have, building and equipment costs that would add up to that. They have building, equipment, equipment, machinery, and labor, right? Perhaps they have, already hired a big staff to come in and refine, assist in the refining of this gasoline. Well, you don't just hire people for free. So they're paying these people to stand there, whether gasoline gets refined or not. Now, obviously, if nothing happens after an hour or so, I'd be like, hey, you're all fired. But in the beginning there, in that opening, when they've refined, they start off refining no gas in the very beginning, they have these building costs, possibly equipment costs, and perhaps they have also labor costs, right? The costs of all these people they've brought in to refine the gas. And that could be a reason they're spending $100,000 an hour, with all the people they're hired, all the equipment they have to maintain, maybe they have taxes on the building, they have to pay for the space, lots of things that could be involved in the adding up to this $100,000 cost before they even refine any gas. And again, if you can think of something else, add to it. But it has to make, of course, again, has to make sense with the problem. I wouldn't say, oh, they rented a bouncy house for the employees that day and nobody refined any gas, and it cost them $100,000 for whatever to hire a carnival to come in. Like that makes no sense, right? Now that could have happened, sure, but it makes no sense based on the context of the problem. The fact that all I was given was this graph, no information outside this graph whatsoever. So this is really all I would probably have to say, is that perhaps there were some building costs, equipment costs, machinery costs, labor costs, taxes, maintenance fees, whatever they needed to pay before they even started the refining of the gas. So I hope that makes sense. And again, this is just one example of many, many, many graphs you will see out there. I think the key to take away is know what a good graph looks like. Properly labeled axes, right? Know what the axes mean, what the variables mean. Also properly distance, all the markings on an axis, all the markings on the horizontal axis represent the same distance. All these were 50 apart. All the markings on the vertical axis also represent the same distance. All of these were 100 apart on the vertical axis. properly labeled, clear graph, starting at 0 on them, just easy to read. And if it's easy to read and properly labeled, then hopefully any question asked about it, like the 4 I had here, will be at least reasonably easy to answer. Okay. So yeah, please don't just take this as the only one. Go out there, look at. You can find graphs all over the place. Graphs in newspapers, weather reports, statistics books, math books, all over the place. You can see them and practice interpretation. Answer questions, make up questions, see if you can answer them, just by looking at the information provided on the graph itself. Okay, so that's really all I have for this. Again, though this is geared toward more intermediate algebra, beginning algebra students, but that's what I've got today for the interpretation of graphs. And as always, I like to say at the end of these, try your best, do the best you can to understand and maybe get the material ahead of time, get the material before you go looking for help. Read the author's material, read the examples the author provides, perhaps even try to work out the solutions to an example before you read what the author did. See if you can learn from mistakes there. And don't just give up after, and practice problems, of course, and don't just give up after the first attempt. Look up answers if you have to, check yourself. But if after several attempts at a problem it's still not clicking, then maybe go back and read the material again. Perhaps a second or third read through of the material is all you need to see something that you didn't see the first time, or have something click that didn't click before. But if after several readings of the material and several attempts at your problems, you're still not getting it, then it is not a sign of weakness whatsoever to go looking for help. That is what other people are there for. Ask a teacher, a tutor, a friend, someone in a class that knows the material and is willing to help. Go looking for supplemental material online. Look for videos on the subject, maybe like this one, or plenty of other ones out there that are better than mine. I assure you, you can find them. But just keep looking, keep at it, keep practicing, stay persistent, and try to have a positive attitude. If you go in it all negative and I hate math, I've always hated math, well, you're going to continue to hate it. It's already set in your mind. Let's see what happens when you go in with an open mind, a positive attitude. Think you're going to get something out of it, and it might just make all the difference. So keep at it, keep practicing, stay positive, and I know you'll eventually get it. Thank you for watching.